Welcome back to the session 2 of triangles. In the last session, we learned the congruency rules of triangles, and even I gave you an activity to draw these triangles and write the congruency rules on a chart. Let's recall these congruency rules and quickly jump to the exercise questions. So for doing exercise questions, for doing this chapter triangles, you must remember these 5 rules. The first rule I said you, the Sss Congruency Rule, in which 3 sides of one triangle, you can see in the first figure here, 3 sides of this triangle are equal to 3 sides of this triangle. So they are congruent by Sss congruency. Then second triangle SAS, the second figure you can see, these two triangles are congruent by SAS. So I said you, here we need 2 sides, you can see 2 sides and included angle, the red dot is the angle which is included between the sides. So when these parts are equal, these two triangles are congruent, I said you. Then I also said you about ASA, okay, angle side, you can see 2 angles of this triangle are equal to 2 angles of the other triangle, and the included side is also equal in measurement. So these two triangles are congruent by ASA. Then AAS also we discussed. The difference between ASA and AAS, you can see here the side is in between the angles, okay, the side is included in between the angles. Here the side is not in between the angles, here it is some other side. So 2 angles and side is some other side, okay. If it would be this side, then it would be AAS, but the side is some other side, so it is AAS. 2 angles of this triangle equal to 2 angles of the other triangle, and one side is equal, so they are congruent by AAS rule. Then we have seen RHS rule. This is applied only for right angle triangle. I said you RHS, that is right, hypotenuse and side. So these two are right angle triangles. Right angle means 90 degrees, okay, both are 90 degrees. Then hypotenuse and hypotenuse, these two are hypotenuse, the longest side and one other side, okay, that is also called HL, but we call it as RHS congruency rule. So these are the rules which will help you, I can say these are the weapons to fight the war, okay. So these are the rules which you should keep in your mind and apply the suitable rule for exercise questions. If 3 sides are equal, we can use this. If 2 sides included angle, you can use SAS and goes on, okay. So today, in today's session, we are going to start an exercise from triangles, okay. Let me show you the exercise. This is exercise 7.1 of chapter triangles. So we are going to prove these all the questions today, step by step, okay. This is very simple, okay. Just we have to keep in mind all the congruency rules. So let's begin with the first question. You can see in the first question, in quadrilateral ABCD or ACBD, its few parts will be equal. Already they will be equal, it will be given in the question, and few parts we can use the rules which we have studied in lines and angles, like vertically opposite angles, alternate angles, corresponding angles. We can use all those rules which we studied, okay, for proving these theorems or questions. So in this in this quadrilateral ACBD, you can see a quadrilateral ACBD here, yeah. AC is equals to BD, it's already given, you can see AC and AD are equal, and AB bisects angle A. AB bisects angle A means I said you in line side angles what is the meaning of bisector. AB bisects angle A. So these two angles will be equal. CAB will be equal to DAB because AB is the bisector. We have to show that triangle ABC is congruent to triangle ABD. We have to prove that this triangle is congruent to the other one. So very simple. Let's see how we can prove this. So let's write what's given. Given is AC is equals to BD. AB bisects angle A. So I can say CAB is equals to DAB. Okay, just now I said you these two things are given. So we have to prove ABC is congruent to ABD. So we can what we can take as third part in this equal. I got two parts already. I got two parts given in the question only. Okay, this is equal to this. This angle is equals to this angle. Then what is the third part I can use here? Yes, I can use the common part in these two triangles. In triangle ABC also we have AB. In triangle ABD also we have AB. Okay, so AB is common part. So which rule I can use here? Yes, I can use SAS rule here. Okay, two sides and included angle. So by SAS rule I can prove that these two triangles are congruent. That's very simple. So let's go to the proof now. Write the steps. In triangle ABC and triangle ABD, I'll write first AB is equals to AB. Just now I said you that is common. Then angle CAB is equals to DAB because AB is the bisector, and AC is equals to AD because they are equal. Already it is given to us. So these two triangles are congruent or not? Yes, they are congruent by SAS congruency rule. So when these two triangles are congruent, what about the other parts? The other parts will also be equal. They are called CPCT. So what are the remaining parts? We'll write them as CPCT. So he is asking you what can you say about BC and BD. So we can say that BC will be equal to BD. That is also they are also equal. They are CPCT. Got it, everyone? So it's very simple, nothing complicated if you understand the basic concepts. Let's go to the next question now. In the second question, ABCD is a quadrilateral in which AD is equals to BC. Here also you can see two sides are equal in this quadrilateral ABCD. AD is equals to BC and angle DAB is equals to angle CBA. These two are also given equal. We have to prove that the triangle ABD, you can see the first bit here, triangle ABD. Where is triangle ABD? The green colored one, ABD, and is congruent to triangle BAC, that is the blue colored. So we have to prove these two triangles, the green colored and the blue colored one, they are congruent. So what is the third part I can take in this? Again, how to prove that they are congruent? Already one angle, one side are equal. Okay, one angle and one side. The common side I can take here also. Again, this is the common side. So which rule I can use here now? Yes, think and tell me quick. It's SAS. Again we can use SAS rule here. Yes, very simple. So let's write what's given first. Given is AD is equals to BC and these angles are equal. We'll write the RTP that is required to prove, or we can write to prove. So these are the things which we have to prove. These two things are given in question only. So in every problem you must write given and to prove, because this will also give you marks. This will be of 1 mark. Now coming to the proof, what I said we'll write step by step and we'll prove in triangle ABD and BAC. So you can see in triangle ABD, this triangle, and the other triangle, the blue colored BAC, what is the first part which is equal? AD is equals to BC. Yeah, just now I said you it's given to us. Then the angle is also equal. DAB is equals to CBA, that is also given to us in the question. So what's given we can use that, and we can use the other parts also, like I'm using the third part, that is common part. So AB is equals to AB, I'm using that is the third part which is common. So two sides and one included angle of one triangle are equal to two sides and included angle of another triangle. So they are congruent by Sss congruency rule. So I can say ABD is congruent to BAC. The first part is proved. Now what do you say about the other parts? When these two triangles are congruent, what do you say about BD, that is this part, and AC? So when those two triangles are congruent, we can say that the remaining parts are equal by CPCT. Okay, so I can say BD is equals to AC, the second bit, and the third bit I can directly prove by CPCT. So BD and AC will be equal, and angle ABD will be equals to, ABD means this angle will be equals to BAC. Okay, this angle. So remaining remaining parts we don't have to prove. We can directly say that they are equal by CPCT. Very simple questions. Okay, go step by step, that's all. Now in the third question, it's given AD and BC are equal perpendiculars to a line segment AB. You can see the figure, AD and BC are equal perpendiculars. So these two are equal perpendiculars, and to a line AB, we have to show that CD bisects AB. We have to prove that CD, this line, bisects AB. Bisects means it divides AB into two equal parts. So what should be our RTP? Our RTP should be OA is equals to OB. If I prove OA is equals to OB, then I can say that CD bisects AB. Okay, CD is dividing AB into two equal parts. So let's see how we can solve this question. So we'll write what's given first. In triangle, in this figure, what's given to us? AD is equals to BC, the first thing, side. Then AD is perpendicular to AB. This is perpendicular to AB. So what will be the angle OAD? This angle will be how much? If it is perpendicular, it will be 90. Then OBC is also equals to 90. So we have got two angles and two sides. Okay, or I can say one angle and one side of this triangle and one angle and one side of this triangle are equal. What is the third part I can use here now? I can use vertically opposite angles. Hope you all remember it. So these two are vertically opposite angles. Since line CD intersects, since line CD and AB intersect, CD and AB they are intersecting, so they form vertically opposite angles. So AOD is equals to BOC. So we have done a theorem on vertically opposite angles in lines and angles. So that also we can use here. Okay, it's not like that we should use only in lines and angles. It can be used anywhere in geometry. Okay, so AOD is equal. So which theorem, which property I can use here? Two angles and one side. Okay, two angles and one side of one triangle are equal to two angles and one side of another triangle. So I can use AAS. Okay, because side is not included here. So I will write all the steps as I wrote before, and we'll say that these two triangles are congruent by AAS rule. Once these two triangles become congruent, then I can say OB is equals to OA CPCT. Okay, this will be equal automatically by CPCT, we say. Okay, so BO is equals to AO, that is CPCT, hence it is proved. This is the way we should proceed with the questions, exercise questions. So whole chapter will be simple. Okay, in the same way we are going to solve. Let's go for the last questions of today's session. LM are two parallel lines intersected by another parallel lines P and Q. So LM, you can see this L and M are two parallel lines. They are intersected by PQ, the other two parallel lines. So we get a parallelogram here. Okay, and this is a transversal. Okay, here we have to prove that triangle ABC, that is the green colored one, is congruent to triangle ABC. Okay, so ACD and ABC are congruent. I can use, now nothing is given here, just two parallel lines, and the other two parallel lines are intersecting those two parallel lines. So here alternate angles are formed, you can see. Okay, here this angle will be equals to this one, and this will be equals to the other one, alternate angle. So I can use the property of alternate angles. So I can say ACB is equals to ACB, this angle is equals to CAD, the other one. Then BAC is equals to DCA. So we got two pairs of alternate angles, and so two angles of this triangle are equals to two angles of the blue colored triangle. Now what is the third part I can use here now again? Okay, that is common part again. So you can see from the beginning we are using the common side as the third part. So I can, which property I can use here now? Two angles and included side is there. So which property I can use here? Yes, I can use ASA rule here. So we'll write the steps now in triangle ABC and triangle CDA. I'll write the angles which we got as alternate angles, and the other angle also which I got as alternate from 1 and 2. Then AC is equals to AC, that is common, as I said you just now. So we can use ASA congruency rule here. That's very simple. So these two triangles are congruent by ASA congruency rule. So practice these questions regularly for your perfection. Thank you everyone.